In this video, we're going to solve question 23 of the 2021 Junior Mathematics Olympiad first round. We're asked to find the radius of the circle that is tangent to all three sides of a triangle ABC that has side lengths 7, 24, and 25. So, in other words, we're asked to find the in radius of this triangle ABC with length 7, 24, and 25. In solving this question, we're going to make use of a formula that relates the area of a triangle, the in radius of a triangle, and the semi-perimeter of a triangle. So that formula is A equals SR. So the area of a triangle is the product of the semi-perimeter of that triangle and then the in radius of the triangle. So let me just draw a diagram here to illustrate what the in radius of a triangle is. So if you have a triangle here and then you have a circle that is tangent to all three sides of this triangle, then the radius of this circle here that is tangent to all three sides of this triangle is the in radius of this triangle and is denoted by a small r. So this here is the in radius of a triangle, and that's what this r here refers to. And then S, which is the semi-perimeter of a triangle, is half of the sum of the side lengths of a triangle. So S is A plus B plus C divided by 2 if the side lengths of a triangle are A, B, and C. So yes, this is what we're going to make use of in solving this question. So let's go ahead and find S, which is the semi-perimeter. Remember, the semi-perimeter is half of the sum of the side lengths of the triangle we're looking at. So in this case, the semi-perimeter will be 7 plus 24 plus 25 divided by 3. So we'll have the semi-perimeter to be 7 plus 24 is 31 plus this is 56. So this is going to be 50. Sorry, it's divided by 2 here, not 3. So this is going to be 56 divided by 2, and therefore the semi-perimeter of this triangle will be 28. Okay, remember, if we're to find the in radius of this triangle, we need to know what the area of this triangle is, and that's the next thing we're going to go about finding. So before we do that, we're going to observe that this triangle here is a right angle triangle. Let me explain why that is the case. So we have the triangle has length 7, 24, and 25, and we have 7 squared plus 24 squared to be equal to 25 squared. Let me just go ahead with just try call it a proof for this. So I'll just rearrange things a bit here to show that this here is true. So if you move 24 squared to the other side, you have 7 squared to be equal to 25 squared minus 24 squared. And this means that 7 squared will be, and when you use difference of two squares here, you have 25 plus 24 times 25 minus 24. And then you have 7 squared to be 49 times 1. And this is true, right? So since this is true, this is also true. So from this we can conclude that this triangle here is a right angle triangle since it satisfies the condition in the Pythagoras theorem. So let me draw this triangle that we have here. So it's going to be something like this. The hypotenuse here will be 25. One side will be 7 and the other side will be 24. And then we'll have an angle, we'll have a 90 degrees angle here. So since we have this here, the area of this triangle that we're given in the question, since it's a right angle triangle, it's just going to be the product of, it's going to be half of the product of the lengths of the legs of this triangle. So that will be 7 here. It's kind of like base times height over 2. So the base here is 24, the height is 7, and we divide that by 2. So the area here is going to be 7 times 24 divided by 2 is 12. So 7 times 12, and then the area will be 84. So the area of this triangle here is 84. So I'll just write that here. So A equals 84. So given that we know the value of A, that's the area of the triangle, and we know the value of S, which is the semi-perimeter of this triangle, we can now find what the in radius of this triangle R is, which is what we're asked to find in the question. So we have 84 here. So since we have A equals SR and A is 84, so 84 equals S is 28, so we have 28 and times R, the in radius, so we'll leave that as R. And when you divide both sides by 28, you have R to be 84 divided by 28. And when you take when you find the quotients of this division here, you're going to have r to be 3. So that means that the correct answer to this question here is C. So just remember that the radius of the circle that is tangent to all three sides of a triangle is called the in radius of the triangle, of that triangle, and that's what we made use of in solving this question. So this is how to solve question 23 on this exam.